Good day, class. Welcome to Plain Tricks in Mathematics. Today, we want to look at another important concept in mathematics: index notation in whole numbers, decimals, and fractions. When we say index notation in mathematics, index notation means writing numbers in index or power form. Therefore, index means power. Let's say you have 7 raised to power of 2 or 7 raised to power 2. 7 is the base number, right? 2 is the index or power. So, index or power tells you how many times you are going to multiply the base number by itself. Now, so 7 raised to power 2 means 7 times 7. So that is what the index notation is talking about. And don't mistake index notation for standard index form. They are different concepts. Let's say you have 1000. If you want to write 1000 in index notation, it is 10 raised to power 3. But if you want to write it in standard index form, it will be 1.0 10 raised to power 3. This is discussion for another day. So they are different concepts. Let's look at other information you need to understand under the index notation. Note, any number raised to power 1 is equal to that number. That is, if I have 5 raised to power 1, is the same thing as 5. Please take note of that. Any number in its natural state is raised to power of 1. For example, if I say 7, 7 is the same thing as 7 raised to power 1. Please take note of that. Then also, 1 raised to any power is still 1. Let's say we have 1 raised to power 20. It is still 1. 1 raised to power 3 is 1. Why? 1 times 1 times 1 times 1. So 1 times 1, 1 times 1 is still 1. So 1 raised to any power is still 1. Please take note of that. Likewise, any number or anything raised to power 0 is 1. Any number or anything raised to power 0 is 1. For example, if I have 2 raised to power 0, it is 1. If I have 1000 raised to power 0, it is 1. If I have x raised to power 0, it is 1. Please take note of that. It is also very important. Now, let's look at index notation of whole numbers. Now, let's say you have 72. Let's define 72 by looking at the product of prime factors. This is 72. This is 2 in 7, 3. Remainder 1. 2 in 12, 6. 2 can still go. 2 here, 1. 2 here, 8. 2 can still go. 2 in 18, 9. Then you can use 3. 3. 3. 1. 2 times 2, 4. 4 times 2, 8. 8 times 3, 24. So 24 times 3, 72. So it is correct. So now I want to express 72 in index notation. So 72 is 2 times 2 times 2 times 3 times 3. So 72 is 2 raised to power 3 times 3 raised to power 2. So that is 2 in 3 places and 3 in 2 places. That is what we call index notation. So let's look at another one. Let's say we have 3 times 3 times 3. So this 3 in multiplication form, right? Then we can express it in index notation by saying this is 3 raised to power of 3. Let's look at another one. Let's say we have 5 raised to power 5. We can express it as 5 times 5 times 5 times 5 times 5. So that's how to express index notation in whole numbers. Now, let's look at index notation of decimals. Let's say you have Let's say you have 0.2 raised to power 3. It's the same thing as 0.2 times 0.2 times 0.2. Alright? So if you want to multiply, you can remove this decimal point first. Say 2 times 2, 4 times 2, 8. You have 8. So the decimal is behind 8. I'm going to move it 3 times, but you remove 3 decimal points. 1, 2, 0. So the decimal will be here. So 0, 0. So the answer is 0.008. Alright? Then let's say you have another one. Let's say you have 0.1 times 0.1 times 0.1 times 0.1 times 0.1. This we can express it in index notation by saying this is 1, 2, 3, 4, 5. This is 0.1 raised to power 5. It's as simple as that. Let us look at index notation of fractions. Index notation of fractions. Let's look at some examples to guide us as usual. Let's say you have 1 over 2 raised to power 3. So that would be 1 over 2 times 1 over 2 times 1 over 2. So this is 1 times 1 times 1 times 1. That is 1. 2 times 2, 4. 4 times 2, 8. So this is 1 over 8. Let's say you have 1 over 27. This will be 1 over 3 times 1 over 3 times 1 over 3. 1 times 1 times 1 times 1, that is 1. 3 times 3, 9. 9 times 3, 27. So this is 1 over 3 raised to power 3. So that's how to perform index notation of fractions. Now, let us look at addition and subtraction of index numbers with different bases. When we started this discussion, I explained that if you have it like this, let's say you have 2 raised to power 7. 2 is the base number, while 7 is the power or index, which is telling you how many times you are going to use the base number to multiply itself. Please don't forget, it is very, very important. Now, let us see how we can add and subtract index numbers with different bases. Let's look at examples to guide us. Let's say you have 2 raised to power 3 plus 3 raised to power 2. And you want to add. Before you can add, you need to express them in multiplication form. Like this 2 raised to power 3 is 2 times 2 times 2, right? 3 raised to power 2 is 3 times 3. 2 times 2, 4. 4 times 2, 8. This is 8. 3 times 3, 9. So this is 17. Alright? Let's say you have another one that says 5 raised to power 3 minus 2 raised to power 4. The same way, you break this one into multiplication form. This is 5 times 5 times 5 minus 2 times 2 times 2 times 2. That is 2 in 4 places. So 5 times 5 times 5. 5 times 5, 25. Times 5 times 5, that is 125. 2 times 2, 4. Times 2, 8. Times 2, 16. So 125 minus 16, that is 109. So that is a simple way to solve this. Let's say you have another one that says 0.5 raised to power 2 plus 0.3 raised to power 4. What do you need to do? We break this one down to be 0.5 times 0.5. This will be 0.3 times 0.3 times 0.3 times 0.3. Alright, now if you want to multiply this, let's take the decimal points away. So we have 5 times 5, 25. Decimal is there, you move 1, 2. Decimal is there. So this is 0.25. Alright? Now, to do this, remove all these decimals. We now have 3 times 3, 9 times 3, 27 times 3, 81. So we have 81. The decimal is there. We're going to move because we took away 4 decimal points. We're going to return them. 1, right? 2, 3, 4. So this one will be here. So this will be 0, this will be 0, right? This is 0.0081. Then we'll add this one together. You know how to do this. place your points here. If you don't know how to do it, watch our previous video on addition of decimals. This will be 2, 5, balance it to 0, 0. So what do you have? 0.2581. If you use calculator, that is what you're going to get. So the answer is 0.2581. So the final answer for this one is 0.2581. So that's how to solve that. Let's say you have 3 over 4 raised to power 2 minus 1 over 2 raised to power 2. How do we solve this? You break it down. This is 3 over 4 times 3 over 4 minus 1 over 2 times 1 over 2. Alright? 3 times 3, 9. 4 times 4, 16. 1 times 1, 1. 2 times 2, 4. You look for SCM because it is subtraction. If it is addition and subtraction, you look for SCM. If it is multiplication and division, you don't need SCM. 16. So 16, 16, 1. 1 times 9, 9. 4 in 16, 4. 4 times 1, 4. So this answer for this is 5 over 16. So that's how to handle addition and subtraction of index numbers with different bases. Now let's look at multiplication and division of index numbers with different bases. Let's look at examples to be our guide. Right? Let's say you have 2 raised to power 3 times 3 raised to power 2. Alright? You expand it. This will be 2 times 2 times 2 times 3 times 3. So this is 2 times 2, 4, 4 times 2, 8 times 9. And the answer is 72. So that's a simple way to solve that. Let's say we have another one that says 3 raised to power 3 divided by 2 raised to power 3. You can expand it and say 3 times 3 times 3, right? Divided by 2 times 2 times 2. Because 2 raised to power 3 means 2 in 3 places. 3 raised to power 3 means 3 in 3 places. 3 times 3, 9 times 3. This is 27. Divided by 2 times 2, 4. 4 times 2, 8, right? So we have 27 over 8. This is an improper fraction. So we take it to mixed number. 3 over 8. Easy. How to solve that. Yeah. Let's look at another one. Let's say you have 0.4 raised to power 3 times 0.2 raised to power 2. Let's expand it. This is 0.4 times 0.4 times 0.4. Right? Times 0.2 times 0.2. So let's use our multiplication style. Let's remove all the decimal first. This is 4 times 4, 16. 16 times 4, 64. Right? The decimal is there. We are going to take it 3 places back. 1, 2, 3. So the 0 point will be here. So this will be 0. So this is 0.064. Right? Now, times, this is, let's remove this decimal first. So 2 times 2, we have 4. So we are going to move 2 places. 1, 2. Alright? So the decimal will be here. 0. Alright? So this is what we did. 4, 1, 2, 0. So this will be 0.04. So we now use this to multiply out. Decimal, this is 64 and this is 4. We now have 2, 5, 6. We move 2 decimal places here. We move 3 decimal places here. All together we have 5. So let's move 5. 1, 2, 3, 4, 5. Then we're going to place the decimal here. So 0, 0. So the final answer for this will be 0.00256. If you press your calculator, that is what you are going to get. Now let's look at the last example. Let's say you have 1 over 4 raised to power 2 divided by 5 over 8. How do you solve this? This will be 1 over 4 times 1 over 4 divided by 5 over 8. So 1 times 1, 1 over 4 times 4, 16 divided by 5 over 8. You know, this is division. You have to change it to multiplication and invert this number. If you don't understand what I'm saying, go and watch our video under division of decimals, fractions, and whole numbers for you to have full details. Now, this will be 1 over 16 times 8 over 5. 8 here 1, 8 here 2. What do we have? We have 1 over 2 times 1 over 5. So this is 1 over 10 or 0.1. So far, so good. That is simple explanations on index notation in whole numbers, decimals, and fractions. Follow all the steps we have explained. I will not have any issue converting numbers into index form, or converting number from index form into natural state. Thank you for watching and listening. Please help to like this video and other videos on our channel. Help us to share this video and other videos on the channel. Make your comments. We want to have your genuine feedback. Likewise, don't forget to subscribe to this channel. See you next time.